Hello everyone, welcome back. Today we'll be continuing our video with protocols and a port number. So these are some of the common protocols that are used in computer network. First, let us revise what we learned from our DNS. So what happens when you're typing a URL in a browser? Like we have discussed, when you type an https example.com or any website that you want to visit, say Facebook, say Instagram, say any websites that you are particularly visiting in your browser, and hit enter, right? A massive internal architecture of protocol happens, right? Happens in a millisecond. So first what happens is the phone book loop, like DNS uses a UDP. We know that. What happens is the computer doesn't know where example.com live, right? It immediately sends a DNS query, right, over a UDP port 53 because it needs a glazing fast answer, right? The DNS server replies with the website destination IP address. That is how your PC gets an destination IP address. So after that, it moves to phase 2, which is setting up the secure roadway, which is a TCP and SFTP protocol. Now that your computer has the IP address, right, it needs to talk to the web server securely, right? So because data integrity and security matters, it initializes a TCP three-way handshake that we discussed already, and which TCP three-way handshake targeting a TCP port 443. Right. Another is, once the TCP connection is looked in, the TLS handshake occurs to encrypt the traffic. So TLS handshake, it is a translation layer security, right? It happens. It occurs. Internally, right? It happens internally. It encrypts the traffic. Basically, it encrypts the traffic which is inside which is shared through a TCP connection. So basically it is that. So now your browser can send a HTTP GET, right, which request inside the secret tunnel, right? The server sends back the website files or resources. So this is basically how it works. Now let's move to our first protocol, which is SSH, secure shell. It uses a port TCP protocol. It uses a port 22. So SSH is a backbone of a remote Linux administration. Obviously, it replaced insecure legacy protocol like Telnet port 23 and RLogin by encrypting all traffic between the client and the server. So why does SSH use TCP and port 22? Okay, imagine you are running the command rm-rf/var/log/custom. So if you use Linux, you might understand rm is to remove. -rf is a flag. Basically what we are saying is to remove this forcefully, and /var/log is an what can we say, folder, or basically a resource that is inside our machine, and /custom. So basically we're trying to remove this to clear out the old logs, right? So if you're using a connectionless protocol like UDP, like we know in UDP, once a packet is lost in a traffic, then you won't have the facility of retransmission, or you won't get that lost packet. So basically if you are using a UDP and a single network packet dropped, right, containing a character at custom, so basically here the server might execute rm-rf. So if it does custom, then the server might accidentally execute the removal of var/log. That means deleting all the log file instead of wiping out the wiping out the old logs. You will be removing all the logs. So basically that happens. But if you're using TCP, which is byte stream tracking, that guarantees every single character arrives exactly as typed, so in the correct order. So if you use this way, then you will be correctly removing your custom or old log. So basically that is why we use TCP over UDP in our SSH. So this is how why a TCP is used, right? Another is why SSH was invented. So SSH was invented by, well, I'm gonna butcher this name, but Yulin, I don't know how to pronounce this, but okay, he was a computer scientist in Finland. So before SSH, before SSH, administration used old tool like Telnet, right? So basically, these tools said everything in a plain text, regular readable text, which allowed hacker to on the same network to read easily and still password. So what he did was, when his university network was hacked, which motivated him to create a SSH. So he designed it to add strong cryptography, basically scrambling data and prevent hacker from snooping or sniffing or user credentials. So basically used for that. So why it is used? Because security is the main reason in SSH. It is an industry standard. It is used for remote management. It lets user log into a server from anywhere in the world and run command as if they were sitting right in front of it. So basically main reason is the remote connection or remote management system that SSH allows us to connect to different kind of server, different kind of different kind of server anywhere in the world, and we can virtually work from our own place as if we were there. So another is secure file transfer. So it provides a secure alternatives for older protocol like FTP, right, where there was it provides a tool like SFTP, which is SSH file transfer protocol. So basically an SSP, which is a secure copy. So basically more adding secure to the file transfer program. Another is tunneling port, which is known as port forwarding. It acts like a private secure tunnel to safely route through an unaccessed or restricted traffic or network services. So basically these are used for SSH. So let's see what kind of question can we tackle in our interview or a viva. So how does SSH handle authentication securely without sending password over the wire, right? You might get shocked because SSH handles authentication securely without sending password. So what happens is it uses asymmetric cryptography, which is private public key pair. The server has your public key obviously, and it is stored in SSH authorization key, right? During login, what happens is the server sends a random challenge encrypted with the public key, and your machine local machine decrypts it using your private key to prove your authentic identity, right? The actual password or a private key never travels across the network. So what is this challenge, right? Let us understand. So what happens here is server generates challenge. So the server creates a random string of data during your login attempt. Then server encrypts challenges. It encrypts this random string using your public key stored on the server. Client receives challenges. The server sends this encrypted package over the network to your local machine. Remember that this random string is encrypted by your public key. So when client start decrypting this challenge, my local machine or your local machine uses your private key to decrypt the package, and when it is encrypted using a public key and it is decrypted using a private key, you will be able to decrypt the package and reveal the original random string. Once your machine combines this random string with and once the client decrypts it, it proves its identity. The machine combines the original random string with this session ID hashes it and sends the result back to the server. Then after this, the server sends the same calculation, right? It performs the same calculation in its parts. It matches the result and you are logged in. This is how basically SSH handles authentication without sending password over the wire. So this is an important concept that you must understand. What is the first thing you change on a freshly deployed Linux server to secure, right? First answer is we have to edit etc/ssh/sshd config. So basically why we did this is to disable root login, so which is permit root login. So we don't want that. So if we allow this, then you can a root can directly log in. So in order to disable it, prevent it, we have to disable it. Another is disable password authentication. We don't want password based authentication. We have to forced key only access, which is SSH key generation. If you are in Linux, if you do SSH key gen or key gen hyphen something, then it will automatically generate a SSH key. So basically, if we have to force it into a key only access, and optionally change the default port from 22, default port is 22, to a non-standard port to reduce brute force attack. So basically that this is, so we have this SSH program to this is just a command to log into a particular server. So I am using -i. It is basically used when you have a specific key, right, a specific key or a path. So basically, yeah, I have a path or a private key, right, and we are going to use our user @hostname. So this is basically a syntax. So let's look at this flag. So if I use SSH-p 443 user @host, so basically it is connected to a custom port number. If I use hash, like I said earlier, it selects a private key file or a public key authentication, and SSH-i, SSH-id RSA user @host, -v is activate verbose debugging output. So it's not used as much as it is written over here, but it's good to know. So another is -x. It enables X11 graphic forwarding to run GUI program remotely, right. Another is -c, compresses data packet during transmission to save bandwidth. So these are basically essential flag, right, we use in SSH. So next is FTP versus SFTP. So which is used it uses a port 21 and 22. 22 is default port number for SSH, and SFTP is the secure file transfer of SSH. So no worries, but FTP is for port 21. It uses a TCP port 21. So what happens is when we move large amount of file like WAV, iOS, or configuration backup file, so we need FTP or SFTP. So FTP is a file transfer protocol. It uses TCP port 21. It is an ancient insecure protocol. It transmits everything, including your administration username and password, in plain text, right? Furthermore, standard FTP uses two port. It uses port 21 for command, right? It uses port 21 for command, and a random dynamic port for data transfer. It uses two ports, 21 for command and a random dynamic port for data transfer, which makes configuration power or nightmare, right? Another is SSH file transfer protocol. SFTP is uses a standard port 22. It is not a FTP wrapped in encryption. It is a completely different protocol, right, built under the ground up to run inside established SSH session. It is run inside a SSH established session. So why we use TCP over here again? So file transfer requires 100% accuracy or data integrity, right? If a single digit flips, right, or drops during a OS patch upload, so imagine you are installing you are awaiting OS patch upload, right? It is basically we are fetching the update from the server, from our operating system server, or it is what it is, right? So if we're doing that, and if we are using a UDP, then the whole, if in between the traffic is lost or the particular resource is lost, then your host system crashes, right? But if you use TCP, it doesn't happen, right? TCP windowing and error checking ensures that every chunk of file is validated upon arrival. So that is why we use TCP. Another is okay, so what are the questions to expect in FTP versus SFTP, right? So what is the difference between FTPS and SFTS? Quite simple, right? It is a FTPS is basically the standard FTP explicitly encrypted or using SSL or TLS, similar to how HTTP becomes HTTPS. It is FTPS is similar to FTPS. Is basically it uses an explicitly encrypted SSL or TLS, right? So it uses a separate command and data channel, right, from the FTP. And SFTP is an extension of SSH protocol, operating entirely over a single port 22, making it much cleaner for firewall configuration and significantly more secure. One major difference you can tell is FTP, I mean, it's not for FTPS. It uses a separate command and data channel, similar to FTP. It uses port 21 for a command and a dynamic port for data transfer, right, which makes a configuration firewall a nightmare. Still, FTPS is far behind SFTP. So basically is that. Another is NTP, sorry, network time protocol is it uses a UDP port 123. So what is a network time protocol, right? So it ensures every computer on a network shows the same exact time. It acts like a master conductor, keeping thousands of separate device clock perfectly synced. So again, this is a really vague. We must understand with the concept what a network time protocol really is. So what is it? So why does it matter? So when a cyber attack happens, right? So investigator must track the hacker movement. If the power clock is 5 minutes ahead of the server time, stitching the timeline is really difficult. It is impossible. So another is working authentication. Modern security system like two-factor authentication or a virus uses time-sensitive digital token. If a server time is drift from the more than a few seconds, then login will fail. So another is database consistency. If two people edit a file at the same exact time, the database relies on a millisecond of accurate timestamp to decide which edit came first. So network time protocol is basically it ensures that every computer, right, every computer on the network shows the exact same time. It is synced in the exact same time. The server and a computer must be synced in a same time, and it is possible with the network time protocol. So how does it work, right? So it has a hierarchical layer which is known as strata, right? So and network time protocol relies on a pyramid system called strata. So stratum 0 device are automatic clock or GPS satellite, and stratum 1 is server connects directly to them, right? And stratum 2 server syncs from the stratum 1, passing the accurate time down the chain. So what is this automatic clock? So automatic clock, it is, I mean, it goes deep into a physics. So it is the clock which calculates exact time from the atomic vibration or something. So just believe it is a global clock, global clock, right? It is a global clock. So another is how does it work is it uses a UDP port 123, right? So it uses a fast lightweight connection. It must use this to constantly exchange tiny time packet between a client and a server. Another is drift compensation. NTP algorithm do not just reset the clock. It calculates how fast or slow your computer internal clock runs and gently speed it up or slow it down to match a global time. So basically to make our computer clock in sync with the global time or slow down with the global time. So basically it is this. So what is the NTP stratum hierarchy? So stratum measures the distance from the reference clock. So just think stratum is like the level or the floor of the building. So it is just a method to describe. So stratum measures the distance from the reference clock. So stratum 0 device are the actual atomic clock or the GPS satellite, and stratum 1 is connected server are directly connected to the stratum 0. Stratum 2 server syncs with the stratum 1 over the network. This is what most enterprise environments syncs their internal domain controller to. The number increases as you move further down the chain. So so why it is mostly used is let me give an example why NTP is necessary. So assume we have a real time, the time is 1 o'clock, 1 o'clock 3 minutes gone, right? So it's a 1:03 p.m. So the database clock is 5 minutes ahead, which is 1:08 p.m. right? So website clock is 5 minutes behind the database, which is 12:58 p.m. right? It is a 12:58 p.m. It is behind a real time. So why the hack works is, so what happens is a hacker assume at 1:02 p.m. At 1:02 p.m. Real time, the hacker withdraws $100 at the ATM. The database uses its own clock and tags it withdrawal at 1:07 p.m. as it is ahead, 5 minutes ahead from the website clock or the real time, right? So now balance is 0, but in website, as it is behind a database, at even though the withdrawal happened, the hacker transferred $100 online, or it transfers the $100 online. The slow website server tags it as a 12:58 p.m. So the website sends the transaction to the database. Now the database looks at the tag, right, at 12:58 p.m. right. It looks at the tag and compares it to the ATM tag 1.07 p.m. and it thinks, oh, the online transfer happened first, right. So because it rewrites history out of order, that's the rule for the database, it approves both, leaving the account at -100. Now NTP stops this by using sure that both machine tag, which is ATM machine tag, and the database machine, website machine tag and the database machine tag, it is at the same clock level, and that the machine tags and the event we have the same exact milliseconds. So that is basically why NTP is really necessary. So if you are in Linux, right, what you can do is, in order to see your if your PC is has activated its NTP clock synchronization, you can check is by time date CTL. If you do this, you can see local time, universal time, time zone, system clock synchronization, which is yes, and NTP service is active. Basically what happens is, as you can see, local time, if my synchronization, system clock synchronization MTP service was deactive, then the local time wouldn't match with my universal time. So because this clock system and NTP service is active, this NTP shifts the display, shifts the time 5 hour 45 minute ahead to match the local time with my current time zone. So basically that is what it happens, it to match with my current zone, and because of this reason I can see the correct time in my computer. So that is how you can see how if your NTP is active or not. So this much for today. I hope I'll see you in the next video. Thank you.